let's take a look at a company that's providing local jobs and keeping our families employed because their product is made on Long Island.
This is the GSE Composites Facility. We're doing large-scale composite structures, radomes, structural components for submarines, large, thick-walled, close-tolerance structures. Directly to my left and behind me is the mold, which is the tool for the lower radome sandwich construction. It houses a radar assembly for an FFG-class frigate. They'll laminate different layers of material, fiberglass and a honeycomb core, which is good electrically, meaning the radar passes through it without obstruction. And then we continue the process with additional layers of fiberglass until we have a structural sandwich. What would be inside would be a radar housing, a rotating radar transmitter and receiver for the shipborne radar system. Directly behind me are leading and trailing edge sections that form the structural members for an antenna for a submarine. Now, we mold those out of fiberglass and a high-strength epoxy resin. The strength has to be in excess of 65,000 psi tensile strength, approximately 100,000 psi flexural strength, and they have to be relatively void-free, perfect laminates. First we mold them, and it's cured in an oven. We introduce the resin in an oven, and then we take them off the mold and cut them down to size. We take the periscope and antenna sub-assemblies. They have to fit in external bearings and slide up and down out of the periscope top without any binding or any noise. Over the entire length of this, we have to be straight within 40 thousandths of an inch, and the ends have to be parallel within 20 thousandths of an inch. We have a special diamond grinding wheel that abrades the composite material and machines it to the required dimension. Each pass takes approximately 15 minutes, and we do it in successive steps until we reach the required dimension. In addition to the outside of the mast, we have to machine the inside structural members. Directly behind me to my left on the small planer miller is a sigma channel, which is created and creates a spar. The leading and trailing edges you saw previously get attached to it, either by bonding with an adhesive or by mechanical fastening. That V that you see in the top actually is described as a right angle on the drawing. It has to be perpendicular within 7 thousandths of an inch down the entire length, some of them up to 23 feet long. During the assembly process, we have to align the trailing edges and the leading edges to the center section because that's where the sensor or the periscope would pass through. So we use optical jig transits and theodolites using special targets. We establish a zero line of sight at either end, and then by moving a target to the middle, we can see the variation and set the mast just so. It's a highly specialized form of inspection. Not only do we use this when we set the mast up for machining, but after machining, all our final inspections on the internal dimensions as well as external contours are done using this technique. This is a finished mast assembly, and we're inspecting the external contour that gets machined on the big planer. We have a target and another jig transit at the far end, and we sight the target down the length of the mast to check the variation against the requirement. When they're done with that, obviously this one has been painted already. We put a tremendous amount of documentation together and test data. We have certifications for every bit of material that goes into the mast. We have structural tests that we do for each part. All the dimensional inspections, the hardware, screws, fasteners that go into the mast are all thoroughly inspected and tested, and that goes to a Navy customer who comes in and checks all of it. Upon completion of that, it goes into a large crate and gets shipped to our Navy customer in Philadelphia. Well, that's the completion of our efforts here at GSE Composites, and you've seen how mast fairings are made right here on Long Island.